May 28, 1940. Reich Air Ministry, Berlin. Hermann Göring reads the intelligence report and puts it down with open disdain. The document describes President Roosevelt's request to Congress for a massive expansion of American aircraft production, 50,000 planes a year. Göring does not take it seriously. He tells his staff the Americans are bluffing, that such numbers are propaganda meant to intimidate. In his view, they do not understand what real war production requires. Converting automobile factories into aircraft plants, he insists, is not something that can be done simply by scaling assembly lines. What he does not realize is that, at that exact moment, the process he dismisses has already begun. In Detroit, William Knudsen, a Danish immigrant and former president of General Motors, is coordinating a transformation unlike anything seen before. He is working for $1 a year as Roosevelt's production chief, applying automotive mass production principles to aircraft manufacturing. Within 4 years, American factories will not only reach the 50,000 aircraft Göring mocked, they will nearly double it. The statement that triggered German skepticism had been delivered on May 16, 1940. As German armored divisions advanced through France, Roosevelt stood before Congress and called for the United States to prepare to produce at least 50,000 aircraft annually. Even American allies questioned it. In 1939, the United States had built just 3,611 military aircraft. The Army Air Corps operated around 1,700 combat planes, many already outdated. Now Roosevelt was demanding an increase by more than 14 times. To achieve it, Knudsen was chosen. When asked who could handle such a task, Bernard Baruch answered simply, "First Knudsen, second Knudsen, third Knudsen." Knudsen left behind a $300,000 salary to take the role. He brought with him a mindset shaped by the automobile industry, standardization, speed, and scale. The change began immediately. By December 1941, American factories were producing 2,000 military aircraft every month. That was 20 times higher than just 2 years earlier. Companies expanded rapidly. Ford announced plans for a massive bomber factory at Willow Run in Michigan. Boeing increased capacity in Seattle. Douglas Aircraft hired thousands of new workers. The United States was turning into what Roosevelt called the arsenal of democracy. German leadership dismissed it. Part of that dismissal came from prejudice. Part of it came from ignoring inconvenient information. General Friedrich von Boeticher, the German military attaché in Washington, sent reports describing the scale of American mobilization. In December 1940, he warned that American production would reach levels difficult to imagine. His warnings were ignored. When he met Hitler earlier, in 1939, the conversation did not focus on data. Hitler dismissed the United States as weak, describing Americans in racial terms and insisting they lacked the discipline for sustained war. This belief spread throughout the system. Reports that women were entering factories were interpreted as signs of weakness, not strength. Information about factories operating around the clock was dismissed as exaggeration. The German leadership simply could not accept what was happening. Meanwhile, Willow Run took shape. Construction began on farmland in April 1941. The result was the largest factory under one roof in the world, 3.5 million square feet, with an assembly line stretching a mile. Charles Sorensen, Ford's production chief, promised something that seemed unrealistic even to Americans: one B-24 bomber every hour. At first, everything went wrong. The first aircraft, completed in September 1942, had to be rebuilt. Defects were everywhere. Half of the output failed quality checks. By early 1943, production stood at just 56 bombers per month, far below expectations. Critics mocked the project, calling it "Will It Run?" But the engineers kept working. They broke the aircraft down into hundreds of subassemblies. They introduced new tools for riveting, standardized wiring systems, and moving production lines. Even as the design changed repeatedly, hundreds of modifications in a single year, production continued. By September 1943, output reached 148 bombers per month. By December, 365. Then came the turning point. In April 1944, Willow Run produced 428 B-24 bombers. That meant one aircraft every 63 minutes, around the clock. One factory was now producing more aircraft than the entire German aviation industry. German pilots began to notice. During the Tunisia campaign in late 1942, Johannes Steinhoff observed that American pilots were improving quickly, and, more importantly, there were more of them every day. By 1943, the pattern was clear. In January, American bombers struck Germany itself for the first time. By October, during the mission over Schweinfurt, the United States could lose 60 bombers and replace them within weeks. The numbers no longer worked in Germany's favor. During Big Week in February 1944, thousands of American bombers targeted German aircraft production. The Luftwaffe lost hundreds of fighters, and, more critically, experienced pilots it could not replace. Adolf Galland reported the situation directly. Germany was losing more aircraft than it could produce. The United States was producing far more than it was losing. The gap was widening. For pilots in the air, the reality was immediate. Heinz Baer, one of Germany's most successful aces, described a mission over Brunswick. The bomber formations stretched across the sky, from one horizon to the other, hundreds of aircraft moving together. His unit had 8 fighters. There was no way to match that scale. The outcome was already becoming clear. By 1944, American aircraft production had reached a level that was difficult to comprehend. In that single year, factories turned out 96,270 aircraft, 16,048 heavy bombers, 35,743 fighters, and 22,591 multi-engine planes. That 1 year alone exceeded Germany's total wartime production of roughly 94,677 aircraft. The difference was not just numerical. It was structural. American bombers carried 13 heavy machine guns, each supplied with thousands of rounds. German fighters, by contrast, were often sent into combat with reduced ammunition loads. American aircraft featured powered gun turrets, advanced targeting systems, and reliable navigation equipment. German pilots sometimes flew without functioning radios. Production rates told the same story. At Boeing's Seattle plant, 16 B-17 bombers were being completed every day by mid-1944. Douglas Aircraft, which had employed just 68 people in 1936, had expanded to a workforce of 167,000 across multiple facilities. North American Aviation was producing 500 P-51 Mustangs every month. Lockheed was completing a P-38 Lightning every 90 minutes while continuously improving the design, introducing more than 2,000 combat-driven modifications. The industries supporting aircraft production expanded just as rapidly. General Motors built over 57,000 aircraft engines under license. Packard produced more than 55,000 Rolls-Royce Merlin engines. Aluminum production increased 6-fold. Magnesium output rose from 6 million pounds annually to over 330 million. At the same time, the American workforce was changing in ways German leadership had not anticipated. In 1941, women made up less than 1% of aircraft industry workers. By 1943, they accounted for 65%, around 310,000 women working in aircraft production. At Douglas and Long Beach, more than half the workforce was female. Workers like Roswell Monroe drove thousands of rivets per shift with near-perfect accuracy. Inspection teams, many of them women, reduced defect rates dramatically. Tools were redesigned to fit smaller hands, which unexpectedly improved efficiency and reduced fatigue. Where German intelligence saw weakness, the reality was increased precision and output. Women proved highly effective in detailed assembly, wiring, instrumentation, and quality control. Their contributions strengthened the system rather than weakening it. Meanwhile, Germany moved in the opposite direction. In February 1944, Göring approved the Jägerstab program, shifting production into hundreds of underground facilities. These sites relied heavily on forced labor. Conditions were severe. At the Mittelwerk complex, around 60,000 prisoners were employed and 20,000 died. Production suffered. Defects increased. Sabotage became common. Moving parts between dispersed factories caused delays. Quality control collapsed. The entire system struggled to function. In some cases, a single American factory produced more engines than these underground complexes combined. While German production fragmented, American industry continued to expand and innovate. Boeing developed modular construction methods for the B-29, allowing components built at different sites to fit together precisely. The aircraft itself incorporated pressurization and advanced systems that Germany could not match in operational form. By early 1945, 100 B-29 bombers were being produced every month. The impact of this production capacity became clear on June 6, 1944. During the invasion of Normandy, Allied forces deployed 11,590 aircraft. German forces responded with just 319 sorties. The ratio was overwhelming. This was not a tactical advantage. It was a result of industrial capacity. In the months leading up to the invasion, Allied bombing had already delivered 145,000 tons of explosives onto German targets, more than Germany had dropped on Britain during the entire war. Transport aircraft moved entire airborne divisions in a single day, using more planes than Germany ever had available for transport operations. By late 1944, individual bombing missions involved more than 1,000 bombers, escorted by hundreds of fighters. The P-51 Mustang could reach deep into occupied Europe, engage enemy aircraft effectively, and operate in numbers that made losses manageable. German pilots began to describe them as everywhere at once. As the war progressed, even German leadership began to acknowledge the scale of the problem. In December 1944, Joseph Goebbels admitted that earlier claims about air superiority no longer matched reality. Rommel had already warned that American production alone could overwhelm any defensive position. Hitler himself later admitted that Germany had underestimated American industrial potential. Albert Speer, responsible for armaments production, confirmed that Allied bombing significantly reduced German output. He stated clearly that systematic attacks on industrial targets had broken Germany's ability to sustain production. Germany's attempt to recover through advanced technology came in the form of the Me-262 jet fighter. It was faster than any Allied aircraft by a significant margin. On paper, it represented a major advantage. In practice, it could not change the outcome. Germany produced around 1,430 of these aircraft, with only a fraction operational at any time. Engines required frequent maintenance. Material shortages forced compromises. Meanwhile, the United States had already begun developing its own jet aircraft. Even while producing large numbers of conventional fighters, it could invest in new technologies at the same time. This difference defined the war. Germany focused on advanced, limited production. The United States combined innovation with scale. In the end, numbers, organization, and sustained output outweighed individual technical superiority. In total war, quality without scale meant very little. When Hermann Göring was arrested on May 8, 1945, by units of the United States 36th Infantry Division, he was forced to confront what had actually happened. At first, he remained defiant. During early questioning in Augsburg, he insisted that German technology had been superior and that defeat had come only because of overwhelming numbers. But as the interrogations continued, especially after his transfer to Luxembourg, where senior Nazi prisoners were held, his position began to shift. In July 1945, during extended interviews with Major Kenneth Heckler, Göring admitted that he had underestimated the scale of American production. He acknowledged that he had known the United States had industrial potential, but the speed and execution had gone far beyond anything he had expected. He spoke specifically about Willow Run, a single factory producing more aircraft than Germany's entire bomber force at its peak. That, he said, had been beyond comprehension. What surprised him even more was logistics. Germany struggled to supply forces even a few hundred miles from its borders. The United States was supplying entire armies across oceans, thousands of miles away, while still increasing production at home. At Nuremberg, the evidence was unavoidable. Prosecutors presented detailed charts showing that by 1944, American monthly aircraft production exceeded Germany's annual output. Footage of assembly lines at Willow Run was shown alongside records of German cities destroyed by bombers produced there. In his testimony in March 1946, Göring admitted that he had believed American industrial potential was significant, but not to that degree. He described the growth as something that seemed physically impossible. Prison psychologist G.M. Gilbert noted that Göring became fixated on production figures. He repeatedly tried to calculate ratios, comparing individual American factories to Germany's entire output. Willow Run became a symbol in his mind. He referred to it as the factory that had broken Germany's back. When confronted with the number of aircraft engines produced, over 800,000 by the United States compared to roughly 240,000 by Germany, he had no response. The numbers spoke for themselves. By the end of the war, the scale of American production had reached extraordinary levels. From just over 3,000 aircraft in 1940, the United States produced nearly 296,000 by 1945. Bombers, fighters, transport aircraft, produced in numbers that reflected not only quantity, but a complete system built for efficiency. At peak, around 2 million Americans were working in aircraft production. The workforce included groups that had never been part of heavy industry before: women, minorities, older workers, younger workers. It was not forced. It was organized participation. People who had entered factories with no prior experience became highly skilled within a few years. And in the process, they changed how manufacturing itself worked. Techniques developed during wartime, statistical quality control, large-scale assembly systems, became standard practice afterward. The same engineers who designed aircraft production lines would later work on space programs. The same workers who built bombers would shape the post-war economy. The economic impact was just as significant. Aircraft production alone consumed tens of billions of dollars during the war. Yet instead of weakening the economy, it strengthened it. Unemployment disappeared. Income levels increased. Workers themselves funded part of the expansion through war bonds. At Willow Run, employees purchased millions of dollars worth of bonds, effectively supporting the system they were working within. Germany faced the opposite situation. By 1944, a large portion of its industrial capacity was dedicated to aircraft production, yet total output remained far below that of the United States. Reliance on forced labor reduced efficiency. Sabotage became common. Quality declined. Productivity per worker dropped as the war continued. At the same time, American productivity increased sharply. The infrastructure created for wartime production did not disappear after the war. It became the foundation for future economic growth. Facilities built for aircraft manufacturing were adapted for civilian use. Materials developed for aviation found applications in housing, transportation, and consumer goods. The system extended beyond factories. The War Production Board coordinated hundreds of thousands of companies. Early computing systems tracked components across complex supply chains. Research institutions developed navigation and targeting systems that improved operational effectiveness. Adaptation was constant. When weaknesses were identified in combat, changes were implemented quickly. Aircraft designs were modified in weeks, not years. Production continued without interruption. Information from the battlefield moved directly into the manufacturing process. This ability to adjust, combined with scale, became decisive. American aircraft were not static designs. They evolved continuously, shaped by real combat experience across multiple theaters. And that flexibility, combined with production capacity, defined the outcome. German aircraft, built in scattered underground facilities by forced labor, remained largely unchanged, while American designs were improving constantly. The difference was not just in production, but in how information moved. Reports from pilots went straight to engineers. Engineers turned those observations into solutions. Those solutions reached the production lines almost immediately. Even assembly workers contributed ideas that fed back into design. This continuous exchange created a system that adapted faster than anything Germany could match. The rigid structure of German command could not keep pace with this flow of information. On October 15, 1946, just hours before his scheduled execution, Hermann Göring wrote his final letter. In it, he admitted what he had resisted for years. He acknowledged that the United States had won through industrial strength rather than battlefield superiority. Germany, he wrote, had not been defeated by better soldiers, but by better factories. He reflected on how a nation he once dismissed as focused only on consumer goods had overwhelmed the Wehrmacht through sheer production. In his last recorded conversation, he described the decision to go to war against the United States as a fundamental mistake. Germany had declared war on an industrial power that had not yet fully mobilized. Once it did, the outcome became unavoidable. He recognized that it was not just production volume, but the system behind it that proved decisive. Every part of it, from organization to execution, had outperformed Germany's approach. That night, Göring ended his life. But his final statements remained as a clear conclusion about the war. A single American factory had produced more aircraft than Germany's entire air force had ever achieved. Historians later reached similar conclusions. The scale of production was the key factor behind Allied victory. Without it, major operations would not have been possible. The invasion of Europe, sustained bombing campaigns, and operations in the Pacific all depended on material superiority. The numbers made this clear. By 1944, the United States alone was producing more aircraft than all other nations combined. This was not a small advantage. It was overwhelming. Germany was not simply losing. It was being outproduced at a level it could not recover from. But the importance of this transformation extended beyond the battlefield. It demonstrated the effectiveness of a system built on cooperation rather than coercion. Workers were not forced into production. They chose to participate. And that choice translated into higher output, better quality, and constant improvement. Göring's earlier dismissal of American industrial capability became one of the most costly misjudgments of the war. His failure to recognize what the United States could achieve contributed directly to Germany's defeat. From the moment he mocked Roosevelt's production targets in 1940 to his final days after the war, the trajectory remained the same. What he had dismissed became the force that overwhelmed everything Germany built. The shift from producing a few thousand aircraft per year to nearly 100,000 demonstrated what a mobilized industrial system could achieve. American factories did not just meet expectations. They exceeded them. They produced more than Germany, even while supporting operations across multiple continents. This was not just about numbers. It was about method. Free workers proved more effective than forced labor. Coordination proved stronger than rigid control. A diverse workforce proved capable of achieving results that centralized systems could not match. The aircraft produced during this period were more than machines. They represented a system that functioned at scale. Every component, from the rivets to the engines, was part of a larger process that kept improving. The factories themselves became as important as the aircraft they produced. In the end, Göring's early confidence turned into recognition of a mistake that could not be corrected. He had dismissed a capability he did not understand. And that misunderstanding became one of the defining factors in the collapse of the system he served.